Okay, so we are to the last lesson in Unit 3, and this lesson takes us from absolute value equations to absolute value inequalities. So we're going to be solving some inequalities that involve absolute value. So there are two ways we can graph absolute value inequalities. On the left-hand side in this diagram, I show an AND inequality and then an OR inequality. So when we have an absolute value inequality with less than or equal to, the graph is an AND inequality. That's a big thing to remember. When we have an inequality that is greater than or equal to, that is an OR inequality. So the way we set up our inequality and how we solve it depends on it being less than or equal to, being an AND inequality, or greater than or equal to, being an OR inequality. So when we get to the actual solving, we have to know the difference between AND and OR inequalities. For example 1, both parts A and B are going to result in AND inequalities. And I'm going to show you a way to kind of set this up to show it as an AND inequality. So an AND inequality, we talked about this before, it always has the less than number, our solution of -2 on the left. That's going to be less than or equal to the expression x plus 7. And that expression is going to be less than or equal to 2. So we have an AND inequality where we have a negative solution and a positive solution. The negative solution goes on the left. The positive solution goes on the right. And then I'm going to solve these each as separate inequalities. And that's just me, just like we solved the absolute value equations, that's just me writing them separately. So the first inequality, I would subtract 7. I get -9 is less than or equal to x. My other inequality, I subtract 7. X is less than or equal to -5. So for me to put these back together, my actual inequality is going to be -9 is less than or equal to x, and x is less than or equal to -5. So writing it as an AND inequality right off the bat, I think helps us. Okay? So this to graph that, I use the little space I have left and really just show me -9, -5, two closed circles because of the less than or greater than or equal to, and then I would shade to the middle with this being an AND inequality. Okay? Now, in this next example, I'm going to explain this one. It says the absolute value of 8x minus 11 has to be less than 0. With this inequality, I am going to say that this inequality has no solutions. And the reason why is absolute value must be positive. And by definition, being less than 0 means that a number is negative, which works against the whole idea of absolute value. So if we get any absolute value inequality less than 0, that has no solutions. If it's greater than 0, that's fine. Greater than 0 means positive numbers. But for less than 0, we cannot get the result being a negative number. So what that means is, when I evaluate my absolute value, my value for x can't make the inside of this 0. What I did before, I wasn't saying the absolute value is -2. I'm saying the value for x can be negative. All right? So that's the distinction we have to have, that an absolute value cannot be less than 0, meaning it can't be negative. So here, I want you to run through these 3 examples on your own, and then check with me once you are ready to move on. So a good chance for you to pause the video, get a little bit of independent practice, and then check your solutions with me. Okay, so as for my solutions, in number 1, all I really had to do was set up the AND inequality, and I didn't have to do any solving because I already had just x. So that one was fairly simple to graph. Number 2, absolute value being less than a negative number means my solutions can only be negative, which doesn't make any sense because absolute value cannot be negative. So number 2 has no solutions because of the less than a negative number. For number 3, I can set up my 2 equations. I can solve them. I got -5 is less than w, w is less than 6. So it's important to set this up as an and inequality right off the bat, knowing that it's less than, and then solving it like we had been solving absolute value equations before. It's very similar to that with a few differences. So we dealt with less than inequalities, less than, or equal to, which means those are and inequalities. For these next 3 examples, these are all greater than or equal to. So these are all or inequalities. So it's understanding that distinction. So the way I would set this up is I would say, for this or, you think of shading out basically. So the way I would set this first one up, c minus 1 is less than or equal to -5, and then c minus 1 is greater than or equal to +5. So I would solve by adding 1 to both sides. C is less than or equal to -4, and then c is greater than, add 1 to both sides, c is greater than or equal to 6. So my solutions, closed circles at -4 and at 6, and the way I would shade is I would shade to the left of -4 and to the right of 6. Because this is an or inequality, we've got to remember when we get our solutions, we shade out for or inequalities. You shade out, you shade away. For part B, now we got a number that's negative. But remember what I said before, those values have to be positive. 0 is okay. Absolute value can be 0. So really, essentially, what this inequality should be written as is if we have values greater than or equal to a negative number, they're just greater than or equal to 0. They don't include -2. So really, the solutions would only include these numbers. So my or inequality is actually going to be just dealing with 0. So my values have to be greater than or equal to 0 here. So my expression, or my inequality I set up, is going to look like this. And then I'm going to solve this. I'm going to subtract 10. I'm going to get -m is greater than or equal to -10. And then I would think of this as a -1. So it's like I'm dividing by -1, which turns this into m is less than or equal to +10. Okay? So I'm just going to have 1 point, 10, close circle, and shade to the left. Now I know that seems weird. Why less than +10 if we're talking about positive numbers? But the value of 10 is the value that we plug into this inequality to show that it's true. So if I substitute in numbers smaller than 10, that's going to give me numbers like 10 minus 9 is 1, 10 minus 8 is 2. And then once I get into the negatives, those are okay because it would be 10 minus -1. Those would be all greater than 0. So that's the idea, is that you've got to be able to solve, you've got to be able to remember some of those properties where I divided by a -1, so I flipped the sign. So those are important properties that still apply in this lesson. And then finally, for the last one, this has a couple of things that we have to be aware of. Our absolute value has a +1 and a ×4 by it. So the way I would solve this initially, before I set up my 2 inequalities, is I would subtract 1 from both sides. So this would be 4 times the absolute value of 2x minus 5 is greater than 20, since I subtracted 1, and then I would divide by 4. So this would become absolute value of 2x minus 5 is greater than 5. So that's the thing to notice, is that we do have to, we talked about this last time, we do have to isolate that absolute value. So my or inequality is going to be 2x minus 5 is less than -5, and then 2x minus 5 or 2x minus 5 is greater than +5. And I should have wrote my or in there. So to solve this, I would add 5 2x is less than 0, divide by 2, x is less than 0. Because 0 divided by 2 is 0. For my other solution, add 5, 2x is greater than 10, divide by 2, x is greater than 5. So this would be, for my graph, points at 0 and 5 that are both open circles, and I would shade to the left of 0 and to the right of 5. So greater than or equal to are OR inequalities. Remember, however you solve it, you know when you get your solutions, you have to shade out. That's the biggest thing. So guided practice, I'm going to go through these. I'm going to have you guys pause the video, check your solutions, and then you're going to move on to a different type of practice. You are going to be practicing using an online version. You do not have to do the paper version of the practice for this lesson. The grade I will record in Infinite Campus for your practice will be the quizzes you do. So when you do the quizzes in the next step, make sure that you use your real name so that I can give you credit for it in the grade book. Okay, so here's a chance for you to look at my work. For number 4, x plus 3 is less than negative 8, or x plus 3 is greater than 8. Solve both of them, plot your solutions, shade out. For number 5, I had to add 3 to both sides before I started my process of solving the absolute value. So I got negative 3. That tells me the only values that really are solutions are values that are greater than or equal to 0. So then when I solved that, I just needed one inequality, and I got values greater than 2. For the last example, I had to isolate that absolute value, so I added 7 to both sides first, then I divided both sides by 3. Then I could have set up and solved my OR inequality. So make sure if I give you one that isn't already isolated before you set up your 2 inequalities, that you get that absolute value by itself. That means getting it so that my inequality was just d plus 1 on one side. That was my goal before I set up my OR inequalities. So again, do the quizzes next. That is your practice. Then do the checkpoint. These things are going to be graded daily to make sure that you are keeping up. So if you don't check in and if you don't do the work, you either get marked absent or you get that missing assignment in the grade book. This is not meant to punish you. I repeat, this is not meant to punish you, but this is meant to keep us going in the same pace that we were doing while we were in person. And then if you have problems with accessing things or you need help with something, you have to email me. You have to email me if you need help with something. I will help you, but you have to communicate that you need help. So let me know that if you need help, send me an email anytime during the day, all right? From 8 a.m. to 3:30 p.m., send me something indicating you need help, okay? And I will do my best to reach you and help you.